Geometry. Just some quick reminders before we get started. First of all, make sure you've turned in your bell work. Also, make sure you turn in your reflections practice from yesterday so that I can see that as well. All right, so here we go. We've talked about translations, which are slides. We've talked about reflections, which are flips. So we are ready for some rotations, which are turns. Okay, so please make sure that by the end of this lesson, you can perform rotations on and off the coordinate plane. Also, please make sure that you can distinguish between reflectional and rotational symmetry. So reflectional symmetry is what we did yesterday. Today, I'm going to introduce to you something called rotational symmetry. All right, so you should be in your packet. It's the very last lesson, lesson 9-4. So let me go ahead and read these intro paragraphs to you here. So it says, for the big finish of the Marching Cougars performance, Mr. Scott arranges the band in a triangle formation. Then the triangle appears to rotate clockwise around a point like a pinwheel. The center of the rotation is the vertex located at 0, 0 on the coordinate plane. Quick side note, 0, 0 on the coordinate plane, do you remember calling that the origin in algebra? Okay, so we'll call it the origin here in geometry as well. So you can see, so he's got this triangle here, so it turns this way, and then it turns again to face this way. So how many degrees would be the rotation from here to here? Ah, very good. If you said 90, you are correct. And then from here to here would be another 90. Or if you want to see it total, all the way from the very first pre-image here to the very last image would be a rotation of 180 degrees. All right, so let's make sure you've also got direction going on here. Okay, so to spin from here to here, notice it goes to the right. Take a look at the clock. You notice how the clock hands always move to the right? Okay, so as the clock goes, that's called clockwise. So think of the motion that the clock makes. If you're going opposite the way the clock would go, that is counterclockwise. All right, so this spinning type of transformation is called a rotation. It is defined by the center of rotation, which is mapped to itself, and the angle of the rotation. Please highlight or underline that. Okay, so two things that you need for a rotation. You need to know its center, and you need to know its angle. The center of rotation may be part of the figure being rotated, as in the case shown above, or it can be a point outside the figure. Functions that describe rotations include xy becoming y negative x, so this is a clockwise rotation of 90 degrees. Repeat the function twice to produce xy becomes negative x negative y. This is a rotation of 180 degrees. Last but not least, we've got xy becomes negative yx. This is a clockwise rotation of 270, or you can also think of it as 90 degrees counterclockwise. All right, so here are some functions we can use to do some rotations on the coordinate plane. They are awfully nice. Also, please make sure that you're remembering that the center of the rotation and the angle of rotation are the two things we need to know to define it. All right, so quick little quote-unquote pop quiz. Make sure that you understand exactly what it is that I expect you to know about a rotation. So when it comes to rotation, what is it defined by? If you said something about the center and the angle, you are absolutely correct. Okay, I must know the center of rotation, the center around which it's rotating. I also must know how far it's rotating, or the angle. Okay. All right, what function is going to represent a clockwise rotation of 90 degrees? If you look back in your notes, very good, xy becomes y negative x. This is really helpful for us to use because while I can look at a rotation and pretty much figure out where it's going to go 90 degrees, it's a lot easier to use the functions in a lot of cases. All right, two more questions. So what's the function then for 180 degrees? Very good. Okay, make sure we've got access to this one here. So xy becomes negative x negative y. And then through 270 degrees, you're right, becomes negative yx. This would be the same as also going 90 degrees clockwise. All right, so based on the rotations that Mr. Scott is having his band do, let's go ahead and fill in the table for both of those rotations. So the first rotation, remember, was just taking the triangle from where it was pointing downwards and making it point to the side. That was a rotation of 90 degrees clockwise. We also have the one where Mr. Scott goes all the way around. So from the very first one to the very last one was 180 degrees. Doesn't really matter if we say clockwise or counterclockwise, you'll end up in the same place. Okay. All right, so when he went clockwise, the point 310 becomes 10, negative 3. Notice how this was done. The y exchanges places here to the first place, and then the x goes all the way to the end and takes on the opposite sign. Okay, so let's see if we can do that for this one. So for this one, the 10 is going to need to go into the first place. The negative 3 goes to the back, but then it also changes sign. So negative 3 would be a positive 3, like that. Okay, 0, 0. So if 0 exchanges places, 0 is going to go to the front here where it's y. 0 is going to go to the back here and take on the opposite sign, which it doesn't really have. Still going to stay at 0, 0. Okay. All right, let's see if we can make it into 180. So 310, I'm going to have to keep the x and y in the same order, but make them both the opposite sign. So it's going to become negative 3, negative 10. All right, and then negative 310 is going to become positive 3, negative 10. 0, 0, doesn't change. All right, and if you look at these points and notice, graph them on one of the coordinate grids above in the paragraphs there, you're going to see that these are exactly where those triangles end up after a 90 and a 180 degree rotation. Awesome, so now that we've seen this in action, let's go ahead and try it ourselves. So remember, one of our goals is to perform rotations on the coordinate plane. So here I have a coordinate plane, I have an arrow. First of all, let's predict the direction of the arrow after these rotations. So if the center of the rotation is 0, 0, so I'm just going about this point right here. If I go 90 degrees clockwise, so imagine that this is an arrow on a clock, okay? If it goes 90 degrees clockwise, it's going to go this direction. So it's going to end up pointing to the right whenever I'm done there, okay? All right, this time I have it pointing up straight, but then if I go 180, that would be 90, this would be 180. So it's going to be pointing the direct opposite way, or down. All right, what if I go 90 degrees counterclockwise? So this time, taking this arrow, but instead of going clockwise, I'm going to go counterclockwise. So if I turn it like this, it's going to now face to the left. All right, they ask us to draw the 3 rotations. So on your paper, go ahead and try drawing the 3 rotations and then come back to the video and see if you got them right. So pause for a second, try this out, and then come check. All right, so let's see how you did, okay? So 90 degrees clockwise, when you turn it to go down here, okay, notice that the arrow is 1 away from 0, 0 right now. So when I rotate it, it's still gonna be 1 away. It's just going to now face this direction, okay? Also notice that rotations are rigid motions, okay? They keep the arrow the same size. So to the best of your artistic ability, please make sure that your arrows are the same size, okay? All right, the 180 degrees. So if I start straight up and then I go all the way around, I mean, it's 1 away from the center. So again, it's going to be 1 away from the center down here. Still going to be a rigid motion, so to the best of your artistic ability, draw in the same arrow there. All right, and then last but not least, 90 degrees counterclockwise. So I'm going to need to take my arrow, I'm going to need to turn it to the left. So it's still 1 away from the center, but this time it's going to need to be here. Okay, so for a better artistic rendering, there you go. These are what the arrows should look like after you've completed a 90 degrees clockwise, a 180 degree rotation, and then a 90 degree counterclockwise rotation. I've inserted this example just for your illustration, so this isn't in your packet. But let's say that I wanted to rotate this triangle 90 degrees clockwise around the origin. So that means that I want the origin to be my center. That means that I want this entire triangle to move 90 degrees this direction. Okay, so imagine it turning around this point in the center. Okay, so think about which direction it's going to point. You know, right now you've got basically you pointing upwards like this. So whenever it turns, then U is going to have to point sideways like this. Okay, so based off of that information, I could make a pretty good guess at where this triangle needs to end up at. Okay, I also want to encourage you though that the T-chart method that you've been using before, where you write in your pre-image and your image, that works too. And in fact, in these cases, if you're not always entirely sure where the rotation ends up at, go ahead and use these. Because rotation of 90 degrees clockwise about the origin, you have a function for that. If you go back into your opening paragraphs, we learned that this is going to become xy, y negative x. Do you remember doing that? So that means that if I list out all my points of u, t, and v, then I can just run them through this function, and that'll tell me where it ends up at. Let's go ahead and try it. So u is at 1, 5. T is at 0, 2. And v is at 4, 2. So if I run this through the function, then that means that these two are going to switch places. And then the x is going to become negative. So it's going to become 5, negative 1. These are going to switch places, so that's going to become 2, negative 0, which really isn't a thing. And then if this switches places, it's going to become 2, negative 4. All right, let's try it out. So 5, negative 1 is right here. Over 2 up 0, that's going to be right there. And then over 2 down 4 is going to be right here. So as I draw in this figure, hey, notice, definitely the same triangle. It's a rigid motion, as it should be, but it looks like it's been rotated or turned 90 degrees to face downwards like this. Okay? Let's keep practicing with these ideas, okay? So look at question 4 on your packet. This time they want you to describe the rotation that would map figure A onto figure B. Okay, so they say first identify the center of rotation, okay? So I have to think about what point would this hinge around in order to make A fall over here onto B. Well, as I look at it, I can see that actually this point right here never moves on either of the figures. It's this point on A, and then when it falls over here onto B, it still stays in the same spot. So that's a pretty key indication that that's our center of rotation. So this is going to be the center 1, 0. All right, now for the fun part, how many degrees? Yeah, it definitely looks like 90 degrees. Looks like it's gone this direction, so as I look at that, it looks like it's going to the right, and so I'm going to call that clockwise. So 90 degrees clockwise. Perfect. Let's try out part B. Now part B is tricky because I look at this and all of the points have moved. That means that my center of rotation is not on either of these figures. It's got to be somewhere in between. Well, if I try to pick one of the points right in between, I can't really get to a point that's like equidistant away from everything that shows a clear angle where they went from each other. But if I move from the center of each figure, like this, there is this point right here. Okay, notice this is 2 away from the center of this figure, 2 away from the center of this figure. And if I kind of make a little angle here, it definitely looks like a 90-degree angle. So I'm going to say that's my center. So this center is at 1, negative 2. This is another 90 degree, but this time we went to the left. So that's not clockwise. That is counterclockwise. So it is possible to rotate about centers other than the origin. We'll tend to do the origin just because it's a little bit more straightforward for us, but please know that there are other rotations available. Go ahead and skip forward in your packet. You need to be on page 124, okay, and it looks like this. So we have now talked about rotations that are on the coordinate plane. Let's talk real quick about how we would do a rotation off of the coordinate plane. So rotations still need centers and angles even when they're not on the coordinate plane. And the notation that we use is a capital R to keep it straight from reflections for lowercase r's. So if you remember, so far we've used a capital T for translation, a lowercase r for reflection, and now a capital R for rotation. In the subscript, we put the 2 things that we need to have a rotation, the center and the angle. Okay, now this is kind of tricky. Go ahead and write this down somewhere on your packet so that you have this for future reference. Okay, for this angle, if I put a positive angle on here, like 90 degrees, that means that I want it to go counterclockwise. If I put an angle on here like negative 90 degrees, that means that I want the rotation to go clockwise. It seems counterintuitive what you would want, but think of it this way. Whenever you get to Algebra 2, we're going to start doing trigonometry on a coordinate plane, and actually this is going to make a lot of sense and have you very well trained by then if you can remember that positive angles go counterclockwise and negative angles go clockwise. Okay, so let's try this out a little bit, okay? So let's say that we were given this triangle, which you have been in question number 11, and you're asked to do a rotation O negative 90 degrees. Well, let's interpret that. That means that this needs to be a rotation. It needs its center to be around O, and it needs to go negative 90 degrees, which remember the negative means that it's going clockwise. All right, so let's try it out. So if this was going to turn around this point, that means, imagine putting like a little stick pin or something through O. The whole thing is going to turn around that, and it's going to go in a clockwise direction. So like A is going to come down here, B and C are going to follow like a clock would up here. Okay, just 90 degrees. So that means that it's going to end up looking something like this. Okay, so notice O stays in the same place. It's just A, B, and C that move. And it looks like it's gone 90 degrees. Okay, let's try the next one. So the next one says that we want to do a rotation again, because that's what the capital R stands for. This time, what is its center? The center is at C, right? And it wants us to go positive 90 degrees. Remember that that is counterclockwise. Okay, so let's try that out. So if my center is going to be C, that means this whole thing is going to hinge around that point. And if it goes counterclockwise, that means that instead of going as a clock would go, this is actually going to go this direction. Okay, so as I rotate this 90 degrees, this is going to basically drop down here, and it's going to face this direction like so. So C stays in the same spot, A ends up pointing down here, and B ends up being there. Okay, so that kind of gives you an idea of at least what's going on with a rotation off the coordinate plane. Again, we don't do it very often. We tend to stick to the coordinate plane, but it helps us if we ever end up in that situation. All right, so just to test your knowledge of the notations, all right, so which one of these would go with a rotation about the center of A, 90 degrees? So if you chose C, you are correct. This triangle is rotated about point A. Remember, positive 90 is counterclockwise, so this is a counterclockwise turn, okay? All right, which of these is a rotation about the center 0, 0, 180 degrees? If you have your eyes on A, that would be the correct one. Notice that this triangle just turns all the way around here with its center at 0, 0. All right, what about a rotation about 1, 1, negative 90 degrees? Well, the only one left is B, and it does fit. So 1, 1 is right here, point A, but it's also the coordinates of point 1, 1. And as I take this figure and I move it 90 degrees clockwise, which is what negative 90 degrees would be, it ends up right there.